Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of direct and inverse proportion. In this video, I will solve the homework problems number 1 which was given in the previous video, that is part 1. So if you have not watched the part 1 video on the direct and inverse proportion where I discussed about direct variation, I highly suggest and request that you please watch that video so that you will have a good foundation of the concept uh, while I will solve the problems. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the homework problems number 1 on the chapter of direct and inverse proportion based on the topic of direct variation. Okay, so I have a different setup. I have the canvas on the right hand side and the homework problems on the left hand side. I hope the fonts are big enough so that you can read the problems. Uh, you can read the problems clearly, even though I have already provided the link to the PDF of these homework problems in the previous video. Okay, now one very important thing I would like to say before starting solving the problems is that after solving the problems, at the end I will discuss all the key concepts and formulas that were used in solving the problems. It is a very super important thing for you, a super important task for you to revise or recall the formulas and concepts that you have used while solving a problem. So whenever you are solving some practice problems, any homework sheet, or any you are giving some test, at the end of the test or solving the problems, always revise the concepts and the formulas that has been used while solving the problem. This will help you. This will keep the concepts and the formulas fresh in your memory for a longer period of time. So always do this, even if the concepts and the formulas are repeated in multiple questions. Always do that at the end of solving some problems or giving a test. Okay. So let's start solving the problems. The first problem says uh, a school recommends a students teacher ratio of 35:1. Next year, school expects an increase in enrollment by 280 students. How many new teachers will they have to appoint to maintain the students teacher ratio? So whatever the number of students and whatever the number of teachers be, the ratio of the number of students and the number of teachers has to be always 35:1. So number of students divided by number of teachers. So uh, give me a moment. I'm trying to set up the canvas properly. Okay. So okay. So as you can see, it says that a school recommends a students teacher ratio of 35:1. Okay. So let's say since we have discussed the theory of the direct variation to quantities, we have always discussed the two quantities. We have given the name x and y, the two quantities which are in direct variation. So let's say x denotes the quantity x denotes the number of students in the school, the number of students, and let's say y denote the number of teachers, the number of teachers in the school. Okay. Now it is very easy, it is very handy if you solve the problems on direct variation or even inverse variation using table. So if you can tabulate few data like this, so we have the two quantities x and y. Now clearly you can see that now the first and foremost thing you must understand from the given problem, that what are the two quantities involved. So in this problem it is the number of students and the number of teachers. Now the next thing to decide is whether the two quantity are in direct variation or inverse variation. Now since I will not talk about inverse variation, since I have only covered direct variation. Only when only when you are confident enough that the two quantities are in direct variation, then we can tabulate some data in a table and apply the formula of direct variation, that is the formula of x1 by y1 is equal to x2 by y2 is equal to, like this, is equal to k, where x1 and y1 is the corresponding values of the quantity x and 1. Similarly, x2 and y2 are corresponding values of the quantities x and y, and all these ratios is equal to the same constant k. This we will apply. Okay. Now, it is given that next year school expects an increase in enrollment by 280 students. It has only given that the number of students in the school will increase by 280 students. We do not know what is the current number of students or the current number of teachers. It is only saying that the number of students will increase in the next year by 280 students. Now it is asking how many new teachers will they have to appoint to maintain the students teacher ratio, Okay, so now so we do not know the current number of students and teacher, and we only know it is only saying that in the next year the number of students will be more by 280. Okay, fine. So let now always always please note one thing, that whenever you need some data and so that data is not available in the problem, you can always assume that data to be some unknown variable x, y or z. Now if you have understood the problem properly and if you can apply the formulas correctly, then those unknown will not bother. By that I mean the actual values of those unknown variables will not be required to solve the problem. So in this problem I do not know what is the current number of students and the current number of teachers. I only know that the number of students in the next year will be more by 280, and I have to find what will be the by how many so how many new teachers will need to be appointed in the next year, which means that I have to find the difference between the number of teachers in the next year and the number of teachers in the current year. Okay, so we have to assume something so that we can apply the concept. So let x1 be the current number of students. Let x1 be the current number of students and y1 be the current number of teachers. So I am assuming that in the current year the number of students is x1 and the number of students is y1. So I can enter this data in the table. So I have x1 and I have y1. So this is for the current year. I do not know what is the values of x1 and y1, but please be confident that these values will not be required. Now in the next year, obviously then the next year the number of students will be more by 280. So I can say so the next year the value of I can say it will be x1 plus 280. So the first column is for the first column, that is x1 and y1 are the data of for the current year, that is x1 is the number of students in the current year and y1 is the number of teachers in the current year, and in the second column x1 plus 280 is will be the number of students in the next year. Now what will be the number of teachers in the next year? I don't know. So let's say that be y2. Let's say that be y2. So I need to find what will be y2 minus y2 minus y1 is what I have to we have to find. So this y2 minus y1 will be the number of new teachers that need to be appointed. Now, okay. So okay. Now what we can say is that, now also note one thing, that it is also given that a school recommends a students teacher ratio of 35 is to 1. That is, if the number of teacher is 1, then the number of students is 35. So I can also enter this value, that is 35. When the number of students is 35, the number of teachers is 1. This data I can also add in the table. So now using this formula, I can get from the table 35 by 1 is equal to x1 by y1. Also let's do one thing. Instead of in the second column, instead of assuming the number of teachers in the second year to be y2, let's say that be y1 plus something. Since the number of students is increasing in the second year, so definitely the number of teachers will also increase. So let's say that the number of teachers in the second year, let that be y1 plus n, where n is the new number of teachers, which is what we have to find. Okay, so we have this. Now this will be equal to, we can say also x1 plus 280 divided by y1 plus n. So we have these three equations, and from these three equations we have to find the small n, where small n is definitely the new number of teachers that need to be appointed. Okay, now okay, first of all, since we have to find small n, we can say using these two equality of these two. So we have 35 by 1 is equal to x1 plus 280 divided by y1 plus n. So this implies, oh, I have no space left. Okay, so this implies 35. If I do cross multiplication, I have 35 y1 plus 35 n is equal to x1 plus 280. Okay. Now also we have this. Okay. Now also from 35 by 1 is equal to, using these two equality, I have 35 by 1 is equal to, I'm really sorry for my very congested and clumsy solutions, sorry for that, but I hope you will be able to make it out. From this I get x1 is equal to 35 by 1. We will use this. So x1 is 35 by 1. Okay. So this becomes, we already got 35 by 1 plus 35n is equal to x1 plus 280. So now x1, we can substitute the value of x1 as 35 by 1. So this is 35 by 1 plus 280. 80. So as you can see, 35 by 1 cancels out, and this implies 35 n is equal to 280, and so this implies n, small n, is equal to 280 by 35, which is equal to, I guess, 35 will divide 280 by, let's divide by 5, 5, 7, 5, 40, no, 5, 7, and 5, 25, and 8. So this is 8. So small n is 8, which means the number of new teachers that need to be appointed is 8, and hence the correct choice is C. C is the correct choice. So the basic idea is that you can assume whatever you feel like, which will make you comfortable in solving the problem and applying the formula, and then you tabulate you create the tables by writing the corresponding values of x and y, the quantities x and y, and then you apply the formula that the ratio x by y is a constant, that is x1 by y1. For all the values that you have tabulate in the table, you apply the formula that the ratio of all the corresponding values is a constant. Okay, let's do problem number 2. Two quantities x and y. I will quickly check whether everything is properly visible or not. Okay. Two quantities x and y are in direct proportion. If x is increased by p%, then what percent will y increase? So x and y, the two quantities x and y are given to be are in direct proportion. So we can say that since x and y are in direct proportion, this is the mathematical way of saying that x and y are in x and y are in direct variation, or x varies directly with y. So we know that if x and y are in direct variation, their ratio x by y is a constant. You can also write y by x is a constant k. It will not matter. It will not matter. But the now x by y, if you consider, but it is a convention that we always assume that the ratio x by y is a constant. Okay, so we have this. Now we have this. Okay. Now it is saying that if x is increased by p%, then by what percent will y increase? Now, so let's say let x1 is equal to increased value of x, by p%. So when x is increased by p%, let that increased value be equal to x1, and y1 is the corresponding value. That is, when the value of a quantity x is x1, then the value of the quantity y is y1. We are assuming, and we are assuming x to be the increased value of x by p%. So we can say, now what is x1? X1 is equal to, now this is the concept of percentage, p% more than x. p% more than x. p% more than x, which is equal to 100 plus p divided by 100 multiplied by x. Now if you tabulate the quantities, we have x and y. Now x and y, uh, so you can consider x and the initial value to be x and y. Now when x is changed to, when the x is increased by p%, its value is becoming x1. So its value is becoming x1. So I can write x1 and y1 as another data in the table. Okay. Now we have to find y1. We have to find y1 in terms of y. Now from this table I can say, from the table I can say that using the fact that the value corresponding values, the ratio of the corresponding values of two quantities is a constant, I can say that x by y is equal to x1 by y1. Okay. Now what is x1 by what is x1? X1 we have already computed to be 100 plus p, 100 plus p divided by 100 multiplied by x. So x1 by y1 becomes this divided by y1. Okay. So this implies, now if you uh, equate these two, from the equality of these two expressions, that is x by y is equal to 10 plus p divided by 100 multiplied by x divided by y1, I can cancel out x and x, and I will get y1 is equal to 100 plus p divided by 100 multiplied by y1. Now this implies, if y1 is equal to 100 plus p by 100 multiplied by y, this means that y1 is p percent p, y1 is p% more than y. So this is a very basic concept of percentage, that if y1 is equal to 100 plus p divided by 100 into y, then y1 is basically, from the concept of percentage, is p% more than y. So in this problem, when x is increased by p%, then y will increase by p%, because we have assumed that when x is increased by p%, if that value is x1, then the corresponding value of y is y1, and we have found that y1 is equal to 100 plus p divided by 100 multiplied by y, which means that y1 is p% more than y, which means that y1, the quantity y will also get increased by p%. So the correct choice is D. The correct choice is D. Okay, let's do problem number 3. The dimensions of a rectangular football ground of length L and width B are directly proportional to the dimensions of a swimming pool of length P and width Q. Then we have, okay, now in this problem it is given that there are two rectangular shapes, that is, one is the rectangular field, football ground, and this other one is the rectangular swimming pool. Now what does it mean when it says that the dimensions of a rectangular football ground is directly proportional to the dimensions of a swimming pool the dimensions of a swimming pool? Now what are the dimensions of a rectangular football ground? Its length and breadth, length and width. Similarly, the dimensions of a rectangular swimming pool is also the length and width. So basically the dimensions of the two, the dimensions considered over here are length and width. Now So if now when it is saying that the dimensions of the football ground is proportional to the dimensions of the swimming pool, it means that the ratio of the length and width of the football ground is equal to the ratio of the length and width of the swimming pool. That is what it means. It is saying that the dimensions are in the dimensions of the two structures of the two shapes, that is, one is football ground and the other one is swimming pool. Their dimensions are directly proportional, which means that if you enlarge if you change the if you change uh, if you change the length or width of the swimming pool, then also then the length or width of the if you change the length or width of the football ground, then accordingly the length and width of the swimming pool will also change, so that the ratio the ratio of their length and width remains the same. I hope I was. So this means that what we so essentially it means that dimensions dimensions are directly proportional. Dimensions now, for the dimensions could be different for different figures. In this problem, the dimensions are length and width, since a football ground is rectangular and also the swimming pool is rectangular. Now, for any other problem, the figure could be something else. It could be circles. If two circles, just as a side note, if two circles, if it is said that the dimensions of two circles are proportional, it means that their radius are directly proportional. Now, if for example, if it is given that for a right circular cone, you know that there is for a right circular cone, if it is given that two right circular cones are the dimensions of two right circular cones are proportional to directly proportional directly proportional, it means that let's say for the bigger right circular cone, the radius of the base is capital R and the height is h, and let's say for the smaller right circular cone, the radius of the base is small r and the height is small h. Then what it means when it is given that the dimensions of these two cones are proportional? This means that h by r is equal to h by small r. So capital H by capital R is equal to small h by small r. This is what it means. So in this problem, the dimensions are length and width of the football ground and the length and width of the swimming pool. So essentially, so we must have L by B. Now you can also consider B by L. It does not matter, but the ratio must be same for both the figures. That is L by B. If you are considering the ratio between length and width, then it must be same for both the football ground and the swimming pool. So the ratio of the length and width of the football ground is capital L by B. It must be equal to the ratio of the length and width of the swimming pool, which is P by Q. So we must have this. Now we have to check which option is correct. Now from here, what do we get? From here, we can say if you do cross multiplication, LQ is equal to BP. So I think the option the choice D is the correct choice. So the correct choice is D. So always remember that when it is given that the dimensions of one figure or one structure is equal to the dimensions of another structure or figure, then the first thing is that both the two structures or the figures must be must look similar. That is, if one is a rectangle, then the other one has to be a rectangle. If one is a square, the other one has to be a square. If one is a circle, the other one has to be circle. If one is a cylinder, the other one has to be cylinder. If one is a cone, the other one is a cone, like this. Now, when the dimensions of the two figures of similar shape are is given to be directly proportional, it means that the ratio of the dimensions of one figure is equal to the ratio of the dimensions of the other figure. So for this problem, the dimensions are length and width. So the ratio of length and width of the football ground should be equal to the ratio of the length and width of the swimming pool. Okay, let's do question number 4. If x and y are in direct variation, then which of the following two quantities are also in direct proportion? Okay, so it is given that okay. So it is given that x and y are in direct proportion, which means mathematically we denote it like x varies directly with y. Okay, so from here directly we can say that x by y, that is the ratio of between them, that is x by y, is a constant. Where k is some constant, we don't know, but k is a constant. Now for this kind of problem, what we have to check? So we have to check whether which of the two quantities are in direct variation. Now if two quantities are in direct variation, the what we have to check is that the ratio is also a constant. Now, so let's check option by option. For the first option, the quantities are x plus 2 and y minus 2. So we need to see whether their ratio is a constant or not. Now, for these two quantities, x plus 2 and y minus 2, their ratio may be some another constant. Now, since we know that the x and y, the quantities x and y are in direct variation, and x by y is k, it is possible, if x plus 2 and a y minus 2 are indeed in the direct variation, then the ratio has to be expressed in the terms of this k. So let's see what is x plus 2 divided by y minus 2. We have to verify whether this is coming out to be a constant or not. Now this constant will not be definitely k, but it should be some expressions involving k. That is, it must be an expression of k. Okay. Now x plus 2, the idea is that from the fact that x varies directly with y, we have x by y equals to k. From this, we will have the value of x in terms of k and y. So we have x is equal to ky. Now in this ratio, that is x plus 2 divided by y minus 2, I will substitute the value of x as ky. So this is x becomes ky plus 2 divided by y minus 2. Now this is definitely this expression is not a constant. As you can see, it is dependent on y. So it is not a constant. By constant, I means that if this expression was involving only the constant k and any other numbers, then it would have been a constant. But since x plus 2 divided by y minus 2 is this expression and it is having the y, we cannot eliminate y. You cannot remove y from this expression. So this is not a constant, not equal to a constant. Not equals to is probably not the correct way of writing, but I mean to say is that ky plus 2 divided by y minus 2 is not a constant, since it has the variable or it has the quantity y. X plus 2 divided by y minus 2 has to be some expression, some value which will not have the quantity x and y in its value or in its expression. So definitely this is not this is these two quantities, that is x plus 2 and y minus 2, are not in direct variation. Okay, let's see the choice B. So we have x plus y comma x minus y. So let's see what is the value of the ratio, that is x plus y divided by x minus y. Similarly, I will substitute x with ky. So I have x is written as ky plus we have y divided by ky minus y. Now from both the numerator and the denominator I can take y as common. So we have y into k plus 1 divided by y into k minus 1. So y cancels out. This is equal to k plus 1 divided by k minus 1. Now this expression does not have involved x and y. It only involves the constant k and some other and some other numbers. So this is also a constant. So this is also a constant. You can consider this value to be k2, but this is also a constant. So the quantity x plus y and x minus y is definitely, they are these two quantities are in direct variation, because their ratio is coming out to be a constant, which is k plus 1 divided by k minus 1, where what is k, what is small k? Small k is the constant of proportionality of the two quantities x and y, that is x by y is equal to k. Now I will not check the other two options, because I know they will not be in direct variation, because all these MCQ problems are single correct choice problems. I hope I mentioned it. No, I'm sorry. So all the, whenever you see problems like this MCQ, only one choice will be correct. Now for the sake of completeness, let me also check whether whether the choice C and D, the quantities mentioned in the choices C and D, they are also not in direct variation. So the quantities are 1 by x minus y, x minus 1, and 1 by y minus 1. Now for these two quantities to be in direct variation, we need to check their the ratio. So it is 1 by x minus 1 divided by 1 by y minus 1. So this is equal to y minus 1 divided by x minus 1. So this is y minus 1, and instead of x I will write it as ky minus 1. So this expression is also not a constant, since it has the quantity y. So since it has the quantity y, it is not a constant. So this is not a constant, since it has the quantity y. Now the ratio if the ratio of the two quantities is coming out to be an expression which is independent of x and y, then that two quantities can be said to be in direct variation. Also we can also check that the quantities mentioned in the option choice D, x square and y cube, they are also not in direct variation. So we need to check the ratio x square by y cube. This is equal to x, we will substitute x as ky, since we know that x by y is equal to k. So this is ky square divided by y cube. This is k square y square divided by y cube. This is equal to k square divided by y. So this is not a constant, because it involves the quantity y, not a constant. Hence these two quantities x square and y cube are also not in direct variation. So the correct choice is B. B is the correct choice. Okay. Let's do problem number 5. An aluminum rod of length L meter having a uniform linear density of m gram per meter is divided into two parts whose length are in the ratio 2 is to 3. What is the mass in gram of the smaller part? Okay. Now it is given that the rod, aluminum rod, is having an uniform linear density. Now linear density means the mass of the rod per unit length of the rod, mass per unit length, that is known as the linear density. So it is given the linear density of the rod is m gram per meter. Okay, m gram per meter. Okay. And now the rod is of length L meter, and it is divided into two parts whose lengths are in the ratio 2 is to 3. Now, we will use the concept of ratio and proportion in this problem. Now, so this was the rod, this was the rod, and the total length is L, and let's say it was divided into two parts with the ratio 2 is to 3. Now, I hope you are aware that so we can easily find what will be the length of the two parts. When we know the ratio of the length of the ratio of the length of the two parts and the total length of the rod, which is L, we can easily find out what will be the length of the two parts. So since so let's say let uh, the lengths let the length of two parts be 2x and 3x, which is based on the given ratio 2 is to 3. So whenever you are given, so this is a concept of ratio and proportion. I hope you are familiar with this. You have already studied ratio and proportion in your previous class 7, and also I think no, ratio and proportion, I don't know whether you have in class 8 or not. Maybe in the future in some later chapters I will see. So if you have two quantities, so this is a side note based on the ratio and proportion. If you have two quantities A and B, if you have two quantities A and B which are in the ratio, let's say x is to y, and you are also given the value of the sum of the values of the quantity A plus B, that is the sum of the quantities A and B is also given as Q, and the ratio of the values of two quantities A and B is given as x is to y, and the sum of the values of the two quantities A and B is given to be Q. Then we know we can easily find out what will be the values of A and B. A will be equal to x, the part corresponding to A in the given ratio, x divided by the sum of the parts x plus y multiplied by the sum of the two values A and B, that is Q. So this is A, and B is similarly y by x plus y multiplied by Q. So applying this concept, now since applying, so you can directly know what will be the length of the two parts when the ratio is given to be 2 is to 3 and the total length of the rod is given to be L. So but I was trying to solve it from the fundamentals, which I will not do. I hope you will understand these two results. So so length of smaller part is equal to, since the ratio is 2 is to 3, so the part 2 will definitely correspond to the smaller part. So the length of the smaller part will be 2 divided by 2 plus 3 and multiplied by L. L is the since L is the total length of the rod. So this is equal to 2 by 5 L. So length of the smaller part is this. Okay, and so let's say this be L1. Let L1 denote the length of the smaller part, which is actually equal to 2 by 5 multiplied by L, capital L, where capital L is the total length of the rod. Now, it is also, now let's tabulate V now. Okay. Now, what are the two quantities which are in direct variation? So, the two quantities are the length of the rod and the mass of the rod. That is the two quantities. Let's say x be the length of rod in meters and let y be the mass of rod in gram. So obviously these two are the quantities involved in this problem, and we can clearly see that these two quantities x and y are in direct variation, because since the linear density is same, which is given to be m gram per meter, which means that the more the length of the rod, the more the mass will be. Now, if the rod was not having uniform density, then we could not say that the more the length of the rod is, the more the mass will be, because at the various position of the rod, the mass could be different. Since it is given that the rod is having an uniform linear density, which means that the mass of the rod is same uh, at is same across every position of the rod in the linear direction. So we can clearly understand that the quantity length of the rod and its mass are in direct variation. Now let's try to create a table. So x and y are the two quantities. Now as a data, let's say so we have L1, and let's say the mass also assume let now I'm not writing in words, but I hope you will understand if I discuss. So let's say L1 is the length of the smaller part of the rod, which we have already calculated to be 2 by 5 capital L based on the ratio and proportion, and let's say M1 is the mass of the smaller part of the rod, that is M1 is the mass of the rod which is of length L, small l1. We have this. Now as another data, now we know L1 in terms of capital L. We have to find what is M1, because the question has asked what is the mass of the smaller part. So the smaller part, the length of the smaller part is 2 by 5 capital L. We have to find M1. Now we need another data in the table so that we can find the value of small m1. Now also note that since it is given that the aluminum rod is having a uniform linear density of m gram per meter, it also says that the 1 meter of the length, 1 meter of the aluminum rod will have a mass of m gram. So I can also say that I can also add the data 1 and capital M. That is when the value of x is 1, that is the length of the rod is 1 meter, then the value of y is capital M, which is in gram, m gram, because it is given that the uniform density, linear density of the aluminum rod is m gram per meter, which means that 1 meter at any position across the entire length of the rod, 1 meter of the aluminum rod will have a mass of m gram. So I can also enter this data in the table. Now I can say that L1 by M1, the ratio of the corresponding values is a constant. From this fact, I can say that L1 by M1 is equal to 1 by M. So this implies L1 was 2 by 5 L divided by M1 is equal to 1 by M. So this implies after solving this, we get small m1 is equal to 2 by 5 m into L. So this is the mass of the smaller part of the rod, 2 by 5 ml. So the correct choice is choice D. Choice D is the correct choice. Okay. Question number 6 is saying that what value of m, small m, in the table below will make the quantities P and Q vary directly. Okay. Now we will apply directly the concept that the ratio of the corresponding values is a constant. So we must have, from the given table, we must have m minus 4 divided by m minus 2 is equal to m minus 6 divided by m. Now this is, you have to solve this, even though this equation apparently does not look like a linear equation, since if you do cross multiplication you will get m square, but this is an equation which is reducible to a linear equation because the m square will get cancelled out from both sides. So anyway, to solve this kind of equation, we apply cross multiplication. We apply cross multiplication and we get m multiplied by m minus 4 is equal to m minus 2 multiplied by m minus 6. So doing the product, simplifying the both sides, we get m square minus 4m is equal to, if you do the product, simplify the right hand side, it will be m square minus 8m plus 12. Okay, so you can see that m square gets cancelled out from both the sides, and now it has become a linear equation in m. So if I bring all the m terms, variable terms, that is m terms, to the left hand side and all the constants to the right hand side, I get 8m minus 4m is equal to 12. This implies 4m is equal to 12. This implies m is equal to 12 by 4, which is equal to 3. So the value of m is 3, and hence the correct choice is B. B is the correct choice. Okay. Let's do question number 7, which are state whether the following statements are true or false. Okay. The first one is if two quantities x and y vary directly, then so do the quantities root x and root y. So it is saying that if the quantities x and y vary directly, then also the quantities root x and root y will vary directly. So let's check it out. So it is given that x is varying directly as y. So this implies we can say x by y is a constant k. This means that x will be equal to the constant k multiplied by y. Now let's see what is the ratio of root x. To verify whether the quantities root x and root y are in direct variation, we need to check the value of the ratio, that is root x by root y. Now root x by root y can also be written as root of x by y. Now x by y we know is k. So this is root over k. When if k is a constant, then root of k is also a constant, but it will be a different constant, but it is a constant. It is a constant. So we can say that root x and root y are also in direct variation, because we have found that the ratio of root x and root y is a constant k1, which is equal to the root over k, where k we have assumed to be the constant of proportionality between the quantities x and y. So this is a true statement. This is a true statement. Part 2. The length of a side of a square and its area vary directly with each other. Length of a side of a square and its area vary directly with each other. Okay. Now, what is so? Let's say um, uh, let length of a square P the be small l. Let L small l be the quantity. Let small l be the um, let small l denote the length of a square. So this implies area let that be let that be capital A. We know that the area is equal to L into L, which is equal to L square, which is equal to L square. Now, so the quantities involved are in this problem. It is asking that whether it is saying that the length of the square and its area are uh, vary directly with each other. So the quantities are the length and the area, length and the area. So for the quantities length and area to vary in direct proportion, we have to see that the ratio is a constant. So uh, L by A. So these two are the two quantities, small l and capital A. So L by A must be a constant. L by A must, whatever that value is, that value should not contain either L or A. Now we can see that small l by A is small l by A is L square, which is coming out to be 1 by L. So this is not a constant, not a constant, as 1 by L contains the quantity L. So if the idea is that if X and Y, if P and Q, so if you are given two quantities and if you are asked whether the two quantities are in direct variation or not, then you will find first the ratio of the two quantities, and if the ratio after simplification, after doing simplification of the ratio, if the ratio contains either uh, the quantity either if the ratio contains at least one of the given quantities, then it is not a then the ratio is not a constant. The ratio must not contain any of the two quantities involved, then only it will be a constant. In this problem we can see that the ratio, first of all, the two quantities involved are length, which is small l, and the area, which is capital A. Now capital A is equal to, we know that, is L square. Now when we have to now to see whether the quantity small l and capital A are in direct variation or not, we have to find the ratio, that is L by capital A. And L by capital A, as we can see, is coming out to be 1 by L, which contains one of the two quantities, that is L, so it is not a constant. So this is a false statement, that is length of a square and its area are not in direct variation. Okay. If one angle of a triangle is kept fixed, then the other two angles vary directly with each other. Now, so we have a triangle ABC. We have a triangle ABC. It is saying that, let's say the B is a fixed angle. Let's say B is angle x degree. Just for we are assuming x is some constant degree. Now x is not we usually do not write the constant. We do not use the letters x, y, z for constant. They are always used for variable. So let's say this is m degree. The angle B is equal to m degree, which is fixed. Now we know that angle A plus angle B plus angle C is equal to always 180 degree. Sum of the three angles of any triangle is equal to always 180 degree. Now we have assumed that it is given, it is saying that if one angle of a triangle is kept fixed. So just for the sake of assumption, we have assumed that we are considering the angle B to be a fixed value. So we have which is equal to m degree. So angle A plus m plus angle C is equal to 180. So this implies angle A plus angle C is equal to 180 minus m. So we have this relation. The other two angles, it is saying that the other two angles are very directly with each other. So for in this diagram, the other two angles are angle A and angle C, and we are having that the angle A plus angle C is equal to 180 minus m, which is also a constant. Since 180 is a constant and the m is also a constant, because in the given problem it is given that one angle is fixed. So if it is fixed means it will not change, it is a constant, and that fixed value we have assumed to be m degree. So m is a constant. So if m is a constant, then obviously 180 minus m is also a constant, which we are representing as k. That is 180 minus m is a constant k. Now if so the two quantities, to understand whether the other two angles, which is angle A and angle C, whether they vary directly or not, we can see that their sum is a constant. Now if two quantities their sum is a constant is not the definition of the fact that they are in direct proportion. If two quantities are in direct variation, their ratio must be a constant, but we are getting the sum in this problem. The two quantities are angle A and angle C. There we are not getting their ratio to be constant, but we are getting their sum to be a constant. So angle A and angle C are not in direct variation. So this is a false statement. This is a false statement. Now we can also verify this statement in another way. Now as you know that two quantities x and y, if they vary directly, then if you increase y, x will increase, and if you decrease y, x will decrease. But in this case, when the sum of two quantities is fixed, the angle A plus angle C is always equal to k, where k is some constant. Now if you increase A, then definitely C has to decrease, and if you decrease A, C will increase. So definitely the angle A and angle C are not in direct variation. So this is a false statement. Part 4 is, it is given that A varies directly with B, that is A and B are in direct variation, and A is equal to small a when B is equal to small b. Then value of A is a small a square when value of B is small a b. So we can quickly create a table. The two quantities are A and B, and these two quantities are in direct variation, as it is given. A is so this means, this mathematically, this notation means that A varies directly with B, or A and B are in direct variation. So now it is also given that A is equals to small a when B is equals to small b. So small b and small a, we have this data, that is small a and small b are the corresponding values of the quantity A and B, that is capital A and capital B. Now then it is asking, then value of A is not asking, it is saying that the value of capital A is A square when value of B is AB. Now if let's try to find out what will be the value of the quantity capital A when the value of quantity capital B is AB. So let's say we have AB here, and we have to find, let's say, this value. What will be this value? So let's say this value is x. So any unknown is always represented by the letters x, y, z, like this. So let's say when the value of capital B is small a b, then the value of quantity A, capital A, is x. So we must have then A by B is equal to x by AB. x by AB. So doing cross multiplication, we get AB is equal to BX. So this implies A square B is equal to Bx. So this implies x is equal to A square P divided by B. So B cancels out and it is A square. So this statement is a true statement, since it is saying that the value of quantity capital A is small a square when the value of quantity B is small a b, which is true. Okay. Let's do 5. It is given that x varies directly with y, and is also given that p, the quantity p and q are in direct variation. So we have this. So x and y are in direct variation. The quantities x and y are in direct variation, and other two quantities p and q are also in direct variation. And it is saying that then the quantity xp will be in direct variation with yq. That is, xp by yq must be a constant, some constant. Okay. Now from this fact that the x varies directly with y, we can say that x by y is a constant. Let's say this constant be k1. And since also the quantity p and q are in direct variation, we can say p by q. Let's say this is a constant, another constant k2. Okay. Now we have to check whether the quantities xp and yq are in direct variation or not. For that, we have to find the ratio of xp and yq. xp and yq. We have to evaluate this expression. We have to find the value of the ratio xp by yq and see whether it is coming some constant or it is coming out to be some constant or not. That is, the value of xp by yq should be independent of x, y, p and q. Okay. So what we can do is that from the fact that x by y equals to k1, this implies x is equal to k1 5, and from the fact that p by q is equal to k2, we can say P is equal to K2Q. So now let's see what is the value of the ratio XP by YQ. This is equal to X is equal to, from this fact, X is equal to K1Y. So this is K1Y multiplied by P divided by YQ. Now this is equal to K1Y. Now P, from here we get P equals to K2Q. So P is equal to K2Q divided by, we have YQ. After simplification, we get this is equal to K1 K2 YQ divided by YQ, which is equal to YQ cancels out. We get K1 multiplied by K2, which is a constant because both K1 and K2 are constant. So we can consider this as another constant, K3. This is a constant because K1 and K2 are also constant, where K1 is the constant of proportionality of the quantities x and y, and K2 is the constant of proportionality of the quantities p and q. So definitely this statement is a true statement, since the ratio of the quantity xp and yq is coming out to be a constant K3, which is equal to K1 and K2. This is a so the quantities xp and yq are in direct variation. So this is a true statement. So this brings to an end in solving the problems. Now it is super important that you always at the end of solving a set of problems, now that problems could be homework problems, or it could be some exercise problems in some books, or it could be some test, your school test, or some reference book. Always try to revise all the key concepts and formulas that you have used that was applied in solving the problems. So for this homework problems number 1, I have quickly listed down all the concepts and formulas used. So the number 1, this is not in order, there are 5 concepts. So the number 1 concept is that if x and y are two quantities in direct proportion, and when x is changed to some value x dash, now how x is changed to x dash, that is not important. Somehow by increasing or by decreasing or by multiplying it, by doubling it, by squaring it, by cubing it, whatever, x is changed to value x dash, then what will be the new value of y, quantity y? So if the new value of the quantity y is y dash, then we can get y dash from this equation, that is x by y, which was the original value of x and y, x by y should be equal to the new value of x divided by the new value of y, that is y dash. Now we already know x dash, so from this equation we will get y dash in terms of x and y and x dash. Now usually, most probably, not most probably, it will be the case that x dash will come out to be x dash will be expressed in terms of x. So from both the sides, x will get cancelled out and you will get y dash in terms of y. So this is one concept that was applied. So when it is given that two quantities x and y are in direct proportion and one quantity is being changed, then you are asked what will be the value of the other quantity. So this is the equation that you must use, which is basically the fundamental equation of condition of the two quantities x and y to be in direct variation. That is, we are just equating the ratio of corresponding values. So initially, when x before x was changed, before x is changed to x dash, the corresponding values are x and y, and when x is changed to x dash, the corresponding values are becoming x dash and y dash. So we must have x by y is equal to x dash by y dash. Okay. The second concept is that when a value p is increased by x%, it becomes 100 plus x divided by 100 multiplied by p, which is, this is a very fundamental concept of percentage, but I thought it is an important concept from percentage which you must already be familiar, but even then, just for the sake of completeness, I have listed down this concept. So when a value p is increased by x%, the new value becomes 100 plus x divided by 100 multiplied by p. Okay. The next concept is that if the dimensions of two rectangular figures, I have considered the figures to be rectangular, but it could be some other figures, like it could be a right circular cone. So if the dimensions of two rectangular figures A and B, where the figure A is having length is equal to L1 and width is equal to B1, and the figure B, which is also a rectangular shape, it is having a length L2 and width B2, if the dimensions of the two figures A and B are said to be in direct proportion, then what it means is that the ratio of the length and width of the figure A should be equal to the ratio of the length and width of the figure B, that is L1 by B1 is equal to L2 by B2. This is what it means. Mathematically, we can use these results when it is given that the dimensions of two rectangular figures are in direct proportion. Now, a rectangular figure has only two dimensions, that is length and width. Now, this concept also applies to other figures like a right circular cone. If you consider two right circular cones, where the first right circular cone is having a base radius of capital R1 and the height of H1, and the radius of the second cone, the radius of the base of the second cone is R2 and the height of the second cone is H2, then if it is given that the dimensions of the dimensions of these two right circular cones are in direct proportion, then you will then what it means is that R1 by H1 is equal to R2 by H2. That is, the ratio of the radius and height of the first cone is equal to the ratio of the radius and height of the second cone. Okay. The next concept is that verifying two quantities A and B to be in direct proportion when A and B are expressions involving the quantities X and Y which are given to be in direct proportion. So the concept is that you are given two quantities X and Y to be in direct variation or in direct proportion. Now you are asked to find whether another two quantities A and B where A is expressed in terms of X and Y and also B is expressed in terms of X and Y. Then you have to check, you are asked to find whether the quantities A and B are in direct variation or not. So the concept or the strategy we apply to solve this kind of problem is that we know that X varies directly with Y. We know this X varies directly with Y. So this will imply that the ratio of X and Y will be a constant. We can consider the constant to be K. So X by Y is equals to K. So this implies X is equal to YK. We are getting X in terms of the constant of proportionality K and Y. Now, since we know that both the quantities A and B are expressions of X and Y, we will evaluate or we will simplify both A and B by substituting X as YK. X as YK. Now, after doing the substitution and simplification, we will find the ratio A by B. We will find the ratio A by B. Now, if the ratio A by B contains only small k means in whatever the expression is coming out to be, that is the ratio A by B, if that value is an expression containing any constant number and k, now instead of k it can be k square, k cube, or whatever, an expression involving only k, then which also means that A by B, the expression A by capital A by capital B will not have the quantities A and B. Then only we say that the ratio A and B is A by B is a constant. That is, it is independent of so we are expressing, since A and B, both A and B are given in terms of X and Y, small x and Y. So definitely A is some expression having X and Y, and B is some expression having X and Y. So we are simplifying A. We are simplifying A by substituting X with the value of YK, since we got X is equal to YK. Now, after simplifying both A and B, we are finding the ratio A by B. Now, that ratio value must not contain the quantity X and Y. If it contains at least one quantity X or Y, then the ratio A by B will not be a constant. In that case, the quantity A and B will not be in direct proportion. And if the ratio A by B do not contains the quantity X and Y but only K, then it is a constant and the quantities A and B can be said to be in direct variation. For example, A can be equal to, let's say, X plus Y, and B can be equal to X minus Y. In this example, the quantities A and B will also be in direct variation if it is given that the quantity X and Y are in direct variation. So this is one example. Now, what does it mean that express A and B by substituting X with YK? This means that, let me explain this point, that express A and B by substituting X with YK means that A is given to be X plus Y. That is, the quantity A is expressed in terms of X and Y. So this we can write as YK, since we know that X and Y are in direct variation, x by y we have assumed to be the constant of proportionality be k. So x by y is equal to k, which means x is equal to yk. So we have phi k plus y, which is equal to, we can take y common, y into k plus 1. So this is what I mean by saying express A by substituting x with yk. Also express B similarly by substituting x with x as yk. So this will be ky minus y, which is equal to y common k minus y. So now if we, when we find the ratio to see whether the quantity A and B are in direct proportion, we need to check the ratio of A by B, whether it is a constant or not. So A by B now becomes A is y multiplied by k plus 1 divided by y multiplied by k minus 1, y gets cancels out. This is equal to k plus 1 divided by k minus 1. This expression does not have any of the quantities x and y. It is independent of x and y. That is, it only contains the constant k. So this is a constant. So this whole expression is a constant. This is a constant. So we say that the ratio A by B is a constant, and hence the quantities, the quantity A and B are in direct variation for this specific example, where it is given A is equal to x plus y and B is equal to x minus y. Okay. So the last concept is very straightforward. It that whenever you see this mathematical symbol, this mathematical notation, it means that x varies directly with y, or the quantities x and y are in direct variation. So we can say that the ratio will be a constant, that is x by y will be equal to k, where k is some constant. So using this result, you can proceed to solve any given problem. So that is all for this video. I will once again say that whenever you are solving a problem, a set of problems, it could be problems from exercise books, or it could be some homeworks, some assignment, and also definitely the homeworks I will give, and any exam or test, always revise all the concepts and formulas that you have used in solving the problems. This way, the formulas and the concepts will remain in your memory for a longer period of time. It is super important. I hope this video was beneficial. It will give you a good idea of how to apply the concepts of direct variation to solve some standard variations of problems. And so if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Very soon I will prepare the next video, where I will solve the problems of exercise 12a from the textbook of author R.S. Aggarwal, which is based on direct variation. So please stay tuned for that video, and yeah, that is all. Thanks for watching, and until the next video, take care and bye.